Welcome to the light theremin explanation. This is a pretty simple project except for the auto calibration codes. So let's get to it. So first thing note, simple circuit. We've got a photoresistor connected. It's got a little 10 kilo ohm resistor connected to ground. You might want to try switching that with a 5 kilo ohm. Just maybe take a voltmeter and figure out what gives you the best range of values. You want a significant change as the light changes. And that's connected to A0. We're going to read off that, and based on how much voltage we got coming to A0, how much light's going to the photoresistor, we will play different frequencies on our speaker. And that's it. It's pretty simple. Anyway, and then we got our speaker. It's connected to ground on one side, and the other side's connected to pin 8, and we're just going to use the tone command to play a tone on it. And what frequency we play depends on how much light is hitting this guy, and therefore what voltage we're getting on A0. So let's look at the code. So we already kind of mentioned it before, how the auto calibration thing works, but that's really the only challenging bit. So quickly again. So we set up our 3 variables, one to hold our sensor value, which we get from analog read, because we'll be comparing it to a bunch of things. So we don't want to keep initializing sensor value in loop or setup, and we don't want to keep calling analog read. It's most efficient just to declare it, so it's always in scope. And then we also have 2 other variables, one to hold our lowest value we see in the first 5 seconds, and one to hold the highest value we see in the first 5 seconds. Again, they're initialized kind of weird, but that is to make sure that our auto calibration code is able to set sensor low to the lowest thing it sees in the first 5 seconds. And by starting it off at the max value, guaranteed sensor low will end up being the lowest value it sees in the first 5 seconds. If you started off at some relatively low value in bright conditions, it wouldn't end up being the correct value. And then we got the same thing going on with our max value, our most bright sensor reading, and we're starting that off at the minimum value for the same reasons. We want to make sure that sensor high after the first 5 seconds is equal to the brightest value we saw. We set our LED pin to equal 13, and we're just using the built-in LED on the Arduino. That's on pin 13. That's going to indicate when we're doing our calibration. So in setup, we set up our pin 13 LED and turn it on just to indicate that we're calibrating, though you can tell because it's not making terrible sounds. Then for the first 5 seconds, well, millis is less than 5,000. So if it's been less than 5,000 milliseconds or less than 5 seconds since the Arduino was last turned on or reset, it'll continually get readings off our photoresistor. So sensor value, we just set that equal to the value we're getting on A0, the value we're getting off our photoresistor. And then if we see a bigger value than we've ever seen before, we set our max value to that new higher value. And if we see a lower value than we've seen before, we set our min value to the value we just saw. And so by doing this over and over again for the first 5 seconds, we will end up with sensor low holding the minimum value we saw, and sensor high holding the maximum value we saw. Also, check this out. We turn the LED pin off afterwards. And then we get into the loop, which is very simple. So we set sensor value equal to the value off our photoresistor, and then we make a new int called pitch, and we map what we're getting off our photoresistor. We're saying that this is the minimum value it's going to be, and this is the maximum value it could be. And then so we map whatever we got off our calibration code to this range, 50 to 4,000. You can play with these numbers. These are the the range of frequencies that the piezo buzzer will put out. 50 is nice and low. 4,000 isn't that high. You can go higher if you really want to bother people. But yeah, 4,000 is probably lots. And then we figured out what pitch we want to play, what frequency we want to play. And so on pin 8, we play whatever frequency we just came up using our lovely map function. And we do it for 20 milliseconds and then wait for 10. And then do it again. And that's it. That's totally it. One thing I'd recommend in the first 5 seconds, I'd recommend waving your hand around just so it gets a reasonable low and high that it would experience when you're trying to play your terrible light theremin. And you can also play with these numbers until it makes the kind of sounds you want. That's about it. I hope this made sense. Thanks for listening.